Okay, this is A2Further Maths Notes. We're on chapter 7 and we're looking at the integration of 1 over the root of a squared minus x squared, and also the integration of 1 over a squared plus b squared x squared. This is the reverse effectively of the start of this chapter where we were differentiating our inverse trig function, so hopefully you might remember some of the results then from there, but generally we're going to be using integration by substitution. There's quite some unusual substitutions we're going to be using to let x equal 2, but we'll see how we get on then from there. So it can be shown that this is our integration by substitution formula. Thus an integral may be transformed into integral with respect to a related variable u using the above result. That's all stuff from A2 Maths. So looking then at example 1, so we're trying to integrate 1 over the square root of 1 minus x squared. Never in your wildest dreams, if you didn't know what you were doing, would you let x equal sine u, but that's what we're going to be able to do in here. And if you remember, we need to find dx by du, so differentiating this, dx by du, of course, then gives us cos u. So we would rewrite this as the integral of 1 over 1 minus x squared dx by du. And we want to try and change everything around there when we can. So subbing in everything we have, the square root of 1 minus sine squared u, because we know our x squared here is this, multiplied then by dx by du, which is cos u. The square root of 1 minus sine squared u and cos u, those two things are going to cancel. So we have that with that. So all we have to integrate then is the integral of 1 du. If you integrate 1, you get u. And if we had this up here, so x is sine u, so u then is going to be sine to the minus 1x. Plus c. If we take a look then, we have a similar example here then for cos, and that gives you cos to the minus 1. We'll take a closer look then at example 2, and we can see if we can get our tan x. So our question here is the integral of 1 over 1 plus x squared dx, and we're going to let x equal tan u. That means dx by du, so differentiating here, if you differentiate tan you get sec squared u, using our substitution formula. It's going to be the integral of 1 over 1 plus x squared dx by du, rearranging then. And our x here is of course tan u, so it's going to be tan squared u. Dx by du is sec squared u, and hopefully you spot again that things are going to cancel out. 1 plus tan squared is sec squared, so they cancel out. So again we're just integrating 1 with respect to u. That gives us u. Obviously we have x is tan u, which I have written up above, and that gives us that u, you can see this okay, can't you, is tan to the minus 1 of x. So this integrated then is tan to the minus 1 of x plus c. And we'll take a look at one of the examples on the other side as well, if we can. Just bear with me, excuse the noise. We'll take a look then, I think, at example 3. So instead of a 1 minus x squared, we're going to have 1 over the square root of 9 minus x squared. And again, just with practice, and the trick here is to let x equal to 3 sine u, differentiating here dx by du. If you differentiate sine, of course you get cos, so it'll be 3 cos u. And rearranging this then, integral of 1 over the square root of 9 minus x squared dx by du. And this then gives us, if you're still with me, 1 over the square root of 9 minus, and again my x here is this, so if you square this you get 9 sine squared u. And remember, the square root of 1 minus sine squared is cos squared, so the square root of 9 minus 9 sine squared is of course then going to be 3 cos u, but the x by the u here is 3 cos u, so hopefully you can eventually see why we've set it up this way. That and that cancel out, so we have the integral of 1 du, and that gives us u. So what's u in this case? We need to be a wee bit more careful here. We know that x equals 3 sine u, so if x equals 3 sine u, then sine u is going to be x over 3, so u then is going to be sine to the minus 1 of x over 3. So we have our u here, so our answer then is sine to the minus 1 of x over 3 plus c. I'm not going to go through example 4 here, but it's a similar one where we let x equals 3 tan u, because it's a 9 plus x squared rather than the square root. And again, you hopefully get used to that. And we have a wee general one here. The next video we'll go through our 2 examples, and then that's this unit finished.